Alright guys, in this video, this is the second stoichiometry video, and so I'm going to incorporate molar mass into it. Alright, so this is the reaction that we're going to be using throughout this video. I like to use the same reaction over and over and over again for the example problems because it really helps show the molar ratio, and this one always has different molar ratios because there's 1, 5, 3, and 4, so none of them are the same. Also, this here written in blue was from the last video. It says the only way to go from one substance to another substance is to use a mole-to-mole ratio from a balanced chemical reaction. So if you want to change substances, like let's say you have CO2 and you want to go to oxygen, you have to use the 3 CO2s and 5 O2s to do that. Okay, so that was just to remind you of what you should already know. And so now let's do this example down here at the bottom. If you burn 10.6 grams of C3H8, how many moles of O2 were consumed? Okay, so let me move all this up. All right. Now, I'm going to write down what's given to me, so I have 10.6 grams of C3H8. And then I'm going to look and see what I'm looking for. So I'm looking for moles of O2. So I know that I have to go from C3H8 right here to O2. So if I have to go from one substance to another substance, I have to use a mole-to-mole ratio to do that. And I can't use a mole-to-mole ratio because I don't have moles, I have grams. So I have to get this to moles first. And the only way to get to moles from grams is to use molar mass. So if we want to go from grams to moles, or moles to grams, we have to use molar mass. And so the molar mass of C3H8, carbon, has a mass of 12. And we've got 3 of them, so that's 36. And hydrogen has a mass of 1, and we've got 8, so that is 8. So 36 and 8 is 44. And that's grams in 1 mole of C3H8. So since I have grams up here, I'm going to have to put grams down here in the bottom. So it's going to be 44 grams of C3H8 in 1 mole of C3H8. And that's this right here is the molar mass of this compound. Alright, so now that I have moles, I can use a mole-to-mole ratio to change substances, right? Because that's how we change substances. So in the chemical reaction, it says that I've got 1 mole of C3H8. So I'm going to put 1 mole of C3H8, and that will react with 5 moles of O2. And that 5 moles of O2 is right here in the chemical reaction. So now, moles of C3H8 and moles of C3H8 cancel, grams of C3H8 and grams of C3H8 cancel. So now if I put these numbers into my calculator, I will get 1.20 moles of O2. And I did that by taking 10 divided by 44 times 5. Alright, so here's the next problem. It says, if 12.6 moles of CO2 was produced, how many grams of O2 were consumed? So this time, I've got 12.6 moles of CO2, and I'm looking for grams of oxygen. So I'm going to write down what I have. So I'm right here, and I want to go over here. And so to go from one substance to another substance, I have to use a mole-to-mole ratio. And I can do that now because I have moles. So in the reaction, it says that I've got 3 moles of CO2, so I'm going to put that down on the bottom because moles of CO2 is on the top. And 5 moles of oxygen goes in the top because that's what I'm looking for is oxygen, right? And the reaction says there's 5 moles. But I don't want to end with moles. I want to end with grams. So in order to go from grams to moles or moles to grams, I have to use molar mass. And the molar mass of oxygen is 16, but we have 2 of them, so that means that this is 32 grams of O2 and 1 mole of O2. And since I have moles of O2 on top, that means I put 1 mole of O2 is 32 grams of O2. So now if I look to make sure my units cancel, they do. And I can put this into my calculator now. And what I end up getting is 672 grams of oxygen. Oops. Okay, now I did that by taking 12.6 times 5 divided by 3 times 32. All right, ignore the ones because I can divide by 1 and multiply by 1 as much as I want, and it's not going to change my answer. All right, let's try another one. So this time, if I have 27.3 grams of water, how many moles of CO2 are produced? So again, I've got 27.3 grams of H2O, and I'm looking for moles of CO2. So I'm going to write down what I have, and I need to make a plan. I know that I want to go from water to carbon dioxide. So I know I have to use a mole-to-mole ratio to do that, because the only connection I have is this balanced reaction, and I know that I'm going to make 4 waters for every 3 carbon dioxides that I make. But I can't use a mole-to-mole ratio quite yet because I can't use a mole-to-mole ratio yet because I have grams. And to use a mole-to-mole ratio, you have to have moles. So I have to get grams to moles, and the only way to go from grams to moles, or moles to grams, is to use the molar mass. And so for water, oxygen is 16, and we have 1 of them, and hydrogen is 1, and we have 2 of them. Oops. So that's 18 grams of H2O in every mole of H2O. All right, so I'm going to put the grams on the bottom to cancel out grams on the top. So there's 18 grams of water in 1 mole of water. All right, so next we can use the mole-to-mole ratio that we know we have to use. And so in the reaction, 4 moles of water are produced along with 3 moles of carbon dioxide. And so that gives me what I want, because I want to end with moles of CO2, and I have moles of CO2 right here. And all my other units cancel out. Moles of water canceled out, grams of water canceled out. So whatever I get after I put this into the calculator is going to be moles of CO2. So what I end up getting is 1.125 or 1.13. And I did that by taking 27.3 divided by 18 times 3 divided by 4. All right, so this time we have 28 grams of C3H8. That's given, and we're looking for grams of oxygen. So I'm going to write down what I have. That's a terrible 8. And so I want to go from here to here. And I know if I'm changing substances, I have to use the mole-to-mole ratio. Can't do that yet. I've got grams. In order to go from grams to moles, or moles to grams, I have to use the molar mass. And we calculated the molar mass earlier for propane. It is 44 grams of propane in 1 mole of propane. So I'm going to put the 44 grams of C3H8 in the bottom, and 1 mole of C3H8 in the top, because I want grams to cancel out. So now that I've got moles of C3H8, I can use that mole-to-mole ratio. So in the reaction, 1 mole of C3H8 reacts with 5 moles of O2. Now, all the other problems in this video were only 2 steps. And this one has an extra one because we don't want to stop at moles of O2. We want grams of O2. And the only way to get from moles to grams is to use molar mass. So we've got moles of O2. We want grams of O2. So I'm going to use the molar mass of O2. And oxygen is 16. We've got 2 of them, so that's 32 grams of O2 in 1 mole of O2. So 1 mole of oxygen will go on the bottom because I want moles of oxygen to cancel out, and that's 32 grams of O2. So now I'm going to check my units. Moles of O2 cancel with moles of O2, moles of C3H8 cancel with moles of C3H8, and grams of C3H8 cancel with grams of C3H8. So I'm left with grams of O2, which is what I wanted to find. So now I can put this in my calculator, and I end up with 102 grams of oxygen. Sig figs would be 1.0 times 10 to the second. Okay, but 102 grams is fine if you're in my class. So that's basically it. I'm going to show you something in this video. You can use it if you want to. I prefer you to just know what you have to do by looking at the problem and analyzing it. But if you absolutely are just not getting it, then this is a way to work through the problem. Okay? So if you have grams of something, we'll just call it A, and you want to get to grams of B, grams of something else, then the first thing you have to do is you have to get to moles of A. Then you can go to moles of B, and then you can get to grams of B. So to get from grams of A, right here, to moles of A, grams to moles is going to be molar mass. And you have to use the molar mass of whatever A is. And then to go from moles of A to moles of B, you have to use a mole-to-mole ratio. And that's from your balanced reaction. And then to go from moles of B to grams of B, you will use the molar mass of B. Now the arrows help you even more because in the first step, to go from grams to moles, up here, grams to moles, the arrow is pointing down, which means the molar mass of A, whatever that substance is, goes in the bottom, so you'll divide by it. And then to go from moles of B to grams of B, the molar mass will go on the top, the arrow is pointing up. Like I said, this is really a last resort to use. You should really know what to do by what the problem is giving. If you need more practice, let me know. I'll be happy to give you some.